This video is the last video for simple regression lab exercise, and we're going to conclude with a two-tail test. Like from the regression result, we can see that beta 2 head is around 1.01, right? So is it sufficient enough to conclude that the true parameter of beta 2 is not zero? Like in this case, can we say like it is linearly related? So we need to run a two-tail test and setting the null hypothesis as if like the H0 is if the beta 2, the real beta 2 is equal to 0. So for the t statistic, we can use the t value given as like you now know better than me. The t's that reported from the regression result are by default setting the hypothesized value as 0, which is exactly our case in this time. Or you can compute it yourself. Like if you run these few lines, you will see that like the t value is 10.6338, which is by rounding it up, it will be 10.634. If you are in Dr. Brief's class, you are going to compute the critical value using Q norm. If you're in Dr. Yan's class, you're going to use QT, and just that like this is a two-tail test, right? Like so it's going to be like the significance level is going to be divided by 2. And as you can see, like the critical values are quite similar, like to each other. And then if you're using if you're using the critical value as decision rule, you can see that like both way will give you like the same results. So we can conclude that the true parameter of beta 2 is, we can reject the null hypothesis that the true beta 2 is equal to 0 at 5% significance level. So if you're using the p-value approach, like it's going to be yeah, that's right. If you're using the p-value approach, you can it's going to be the same. So this one will give us the right tail p-value, and by symmetric the left tail is the same, so we need to times 2. So and as you can see, this is true, so we can reject the null hypothesis that beta 2 is equals to 0 at 5% level. And if you do not want to change the lower dot tail to false, like by default is true, you can use 1 minus, which will also still give the same the p-value in the right regions, and times 2 you get the same result. For Dr. Brief's class, like you're going to use the p norm, right? So you can see that like it returned exactly the same. So for the third case, we're going to reject the null hypothesis that like beta 2 is not equal to 0. It's equal. We are going to reject the hypothesis test that like beta 2 is equal to 0, and we can at the 5% significance level.